Introduction. Hey, thanks for checking out this video, which is a 2025 update on Shenzhou stove manufacturer SSM, including descriptions of several high combustion efficiency stoves and how they're adapted to try to meet cooking requirements in different countries. Here's Mr. Shen in the ceramic workshop. In 2004, the Shell Foundation hired Aprovecchio to manufacture ceramic rocket stoves in India. Eventually, it was decided that SSM, expert in refractory ceramics, would manufacture the stoves. For decades, SSM has produced lightweight, abrasion-resistant refractory ceramic combustion chambers. They're so light they float on water. Perfect. Carbon credit projects appreciate the high thermal efficiency and extended lifespan. As Aprovecchio experienced, expert manufacturing is needed to produce the affordable, installative ceramic combustion chambers envisioned by Dr. Winiarski, the rocket stove inventor. Mr. Shen in manufacturing. Since 2007, SSM has sold around 6 million wood and charcoal burning rocket stoves worldwide. Mr. Shen and Aprovecchio also designed health and climate cook stoves in collaboration with the Gates-funded Global Health Labs. This video shows various high combustion efficiency stoves and explains how health and climate stoves can be made to meet different cooking requirements. Extensive field testing has proven that to be successful, any type of stove must please the cooks, be in use. It is so important to always do field testing. Mrs. Shen. Mr. Shen, CEO, Engineers Solutions. His wife, Helen, is a COO and runs the business side of SSM. Around 160 people work at the factory. Most of them live in nearby farming communities. SSM is surrounded by rice fields and vegetable gardens. It is very pretty. The staff includes English and French-speaking salespeople, engineers, and carbon credit facilitators. Mr. and Mrs. Shen and the staff are great hosts, and a visit to SSM introduces visitors to wonderful technical and cultural experiences, and Tier 4 hotels are $50. Travis in the lab. Especially when developing super clean burning stoves, emissions have to be quantified. SSM has had a lab for 5 years with a recent upgrade. Travis Volpe from ARC installed new Python software and spent a week fine-tuning systems. Low PM is great, but now making 95% white smoke, not black carbon, is helpful to protect climate. Luckily, forced draft jets through charcoal produce white smoke, while burning wood tends to make black smoke. Our 2024-25 health climate cook stove emission goal is Tier 4 PM 2.5 with white filters. High power fan stove. A big issue with forced draft T-LUDs has been achieving an adequate turn-down ratio. Some stove companies turn to larger and smaller combustion chambers for high and low power. Well, it took a lot of adjusting of the volume and velocity of the primary and secondary air jets, but Mr. Shen was successful and created a 2-to-1 turn-down ratio by pushing a button that controls the fan speed. That's easier than switching combustion chambers. The firepower used for successful cooking varies a lot from country to country. Very generally, Chinese cooks can require 10 kilowatts, while in certain regions in Africa, and especially in southern India, moderate to low firepower is much more common. SSM adjusts the firepower to try to suit the cooking style by changing the diameter of the combustion chamber. A combustion chamber 145 mm in diameter creates high power around 7 kilowatts with low power at around 3.5. 115 mm in diameter results in 4.5 kilowatts high and 2.3 kilowatts low power. The depth of the combustion chamber determines the length of the burn. Moderate power fan stove. Lowering the firepower in this forced draft tea lead by reducing the diameter of the combustion chamber to 115 mm also required a new higher pressure fan, different configuration and size of holes for the primary and secondary air jets, etc. The devil is in the details for sure. Engineered T-lead fan stoves burning pellets should be around Tier 4 for PM 2.5. CO is usually Tier 5, and even without a skirt, the thermal efficiency can be around 50% or so because the gas temperatures are very high and there's a big lift from radiation. The SSM staff tried lots of combinations to make this stove. Changing one variable at a time and testing a result under the emissions hood can take months, but the good news is that you eventually get there. And it's fun to make something better. A brick jet flame. Making a stove from bricks can protect the fire from wind. 3 7 mm high stones can be the pot rests, forcing the hot gases to flow close to the bottom of the pot. The jet flame increases the temperature of the hot gases, and the mixing combines flame, air, and smoke together to reduce emissions. As mentioned, blowing air through charcoal surprisingly makes white smoke. Unfortunately, the mass of bricks reduces thermal efficiency because the heat from the fire is absorbed by the mass. Moving the mass stove body as far away from the fire as practical reduces losses. Without a pot skirt, this type of stove can achieve somewhere in the 30% range. A pot skirt with 7 mm channel gap can increase thermal efficiency by around 20 to 25%. Jet flame with super pot. When the wind isn't blowing, a jet flame without a complete windshield can direct very hot gases up into a super pot. A fecral sheet metal wall holds the sticks on top of the jet flame. Normal pots can be used as well. The super pot is manufactured by SSM. A fixed pot skirt creates the narrow channels next to the sides of the pot, increasing the exposed surface area. Like a pot skirt, the super pot decreases fuel use by around 20 to 25%. The UNHCR tested and recommended the pot stove after experiences in refugee camps in Africa. This type of stove increases thermal efficiency into the 40% range. The jet flame Baldwin. The Vita stove, a pot skirt stove with sunken pot, was invented by Dr. Sam Baldwin in 1987 in West Africa. The Vita stove with 7 mm channel gap and a 26 centimeter in diameter pot can achieve around 50% thermal efficiency. Aprovecho and SSM made the Vita pot adjustable, so pots of various sizes can be used. Adding a jet flame increases combustion efficiency, resulting in lower cost stove with high range thermal efficiency and lowered emissions. As mentioned, we get a lot less black carbon. The Vita stove can be long lasting because the metal walls of the skirt are not exposed to high temperatures, and as with all stoves, field testing is essential. 2025 news. SSM and Aprovecho are currently working together to manufacture biomass heating stoves. Making and testing low-emission cook stoves has shown that close to complete combustion can be achieved, are you ready? By metering how much wood gas is introduced into the combustion chamber, maintaining temperatures above 850 C for at least 02 seconds in an air-rich and well-mixed environment. Applying these learnings to heating stoves has been supported by the DOE, the Osprey Foundation, and EPA. SSM is investing around $5 million USD in new machinery and buildings, and we look forward to supplying the USA and Europe with heating stoves burning renewably harvested wood that are clean enough to protect urban health and climate. It is so great that R&D intended for the South has applications in the North. Our heating stove emission goals are PM 2.5, less than 0.3 grams per hour, less than 5% black carbon, with very low methane, NOx, etc. Thanks to the Osprey Foundation, we have a new heating stove lab at Aprovecho, and we'll be building one soon at SSM. Please get in touch with any questions.